Okay, so this is review over systems. All right, so first we're going to start with graphing. On this first problem, both equations are solved for y, so it makes it pretty easy. The number without the letter is your y-intercept, and then the number with the letter, that is your slope. So for this first line, I'm going to start at positive 2. And then my slope, a whole number of 3 is the same thing as 3 over 1. So the top number tells me up or down. Since it's positive, that's going up. The bottom number tells me left or right. Since it's positive, it's right. So I go up 3, 1, 2, 3, to the right 1. Now, you can reverse that to get the other side of your line going down. So I can go down 3, 1, 2, 3, and to the left 1. All right, then use a straight edge. I do not have a ruler, so I'm just using this to draw a straight edge. All right, the second one, I'm going to start at negative 3. And my slope is 1 over 2. So that's up 1 to the right 2. Up 1 to the right 2. And again, I can reverse that by going down 1 to the left 2. And you can already see where these two lines are going to intersect. And remember that the intersection point is the solution to our system. So our answer here is going to be negative 2, negative 4. All right. Okay, so for the second one, this is not in slope-intercept form, meaning it is not y equals. So we're going to have to solve both of these equations for y. So I'm going to start with the first one. So x minus y equals 4. So again, I want y by itself, so I'm going to move the x. It's a positive x, so I'm going to subtract x from both sides. Those cancel. I'm left with negative y equals. And I cannot combine these because this does not have a letter and this is a letter. So we cannot combine this. So it's just 4 minus x. Now we can never leave a negative with our y. So you got to imagine that there's really a 1 there. It's really negative 1 times y. So then we're going to divide everything by negative 1. And we get y equals negative 4 plus x. Because negative divided by a negative makes a positive. And x over 1, or x divided by anything divided by 1, is just going to be that thing. So now we're going to start at negative 4. Now, my slope is really 1, right? So it's 1 over 1. So it's up 1 to the right 1. And again, if you went backwards, down 1 to the left 1. All right, and then we're going to draw this line. Again, just use whatever straight edge you have available if you don't have a ruler. All right, for the second one, so I have 5x plus y equals 2. So again, I want y by itself, so I'm going to subtract 5x from both sides. And I get y equals 2 minus 5x. The number without the letter is going to be your y-intercept. So start at positive 2. And then negative 5 is my slope. Remember that that's negative 5 over 1. So this is down 5 to the right 1. Because this one's negative and this one's positive. Remember that the negative has to attach to either the top or the bottom, but not both. So down 5, 1, 2, 3, 4, 5, to the right 1. So you already can tell where they're going to intersect. Makes it pretty easy. So they intersect right here, which is coordinate point 1, negative 3. Okay, so you're going to do the other two. And they should be pretty easy. Follow those two examples. All right, then we're going to look at substitution. Okay, there's different ways to do substitution depending on what you have. So in this case, we have where both of them equal y. You technically could graph this, but these would not be fun to graph because they're larger numbers. So instead, we're going to use substitution. So we're going to substitute everything that's here in for the y into the first equation. Or if they're both equal y, then they equal each other. So I have negative 3x plus 12 equals negative 6x plus 18. All right, my first step is I'm going to get the x's together on the same side of the equal sign. Okay, so this is like your upside down T stuff. So if I want to move this negative 6 and put it over here, I'm going to use opposite operation. So I'm going to add 6x to both sides. Now when I add 6x, I'm going to add it to the negative 3x because these are like terms. So 3x plus 12 equals 18. Now I'm going to move my positive 12, so subtract 12 from both sides. I get 3x equals 6, and then divide by 3, and I get x equals 2. Okay, so I got part of my solution, so I know that x equals 2. So now what I'm going to do is I'm going to substitute that back into one of the two equations. It doesn't matter which one, but instead of writing an x, I'm going to substitute in the number 2. So I'm going to use the first equation. So I have y equals negative 3, and instead of x, I'm writing 2 because that's what x equals, plus 12. So y equals negative 6 plus 12, so y equals 6. So then I write my solution as 2, 6. The x coordinate always goes first, and then the y coordinate. All right, you're going to do the same thing for 6 and 7. So you just make the equations equal, set them to equal each other, and then solve for your x. Once you have your x, then plug it back in to one of the two equations to solve for y. Another way you'll see substitution is if only one equation is solved for y and the other one is not. So in this case, I'm going to take everything that y equals and I'm going to substitute it in where I see a y. Okay, so it tells me that y equals this expression. So instead of writing y, I'm going to write this expression. That way I have an equation with only one variable, not two, so that I can solve it. So it'll look like this. Negative 2x plus 2, but instead of y, I'm going to put parentheses, and I'm going to write down this expression. Negative 2x plus 6. Then I go back up here and I write the rest of that equation, so equals 12. So we start with distributive property, so negative 2x. 2 times negative 2 is negative 4x. 2 times 6 gives me 12, equals 12. Combine like terms, so negative 6x plus 12 equals 12. Subtract 12 from both sides. Negative 6x equals 0. Divide by negative 6, and we get that x equals 0. Now I'm going to take that and I can plug it back into either one of these equations for x. But if you use the one that is y equals, it's a lot easier to solve because it's already set up for us to solve for y. So y equals negative 2 times 0 plus 6. So y equals 0 plus 6, so y just equals 6. So then my solution is 0, 6. And again, you write your x coordinate first and then your y. Okay, just to recap one more time of what we did here. So what we did is we took, when you have one equation that is in standard form and your other equation is y equals, we took everything that y equals and we substituted in there. Notice in this equation right here that there is no y's in there at all. We only want one variable so that we can solve it. Then we solve for x. Once you got x, you plug that back in to the y equals equation for x, and you solve and you find your y. So 9 and 10, you can do that the exact same process. You're going to be substituting all of this negative 2x minus 8 in for that y. And here you're going to take this negative 7x plus 14, and you're going to substitute it into that y right there. Okay? All right, and then we have elimination. So for elimination, we want to eliminate or get rid of one of our variables by adding. Okay? In order to eliminate something by adding, you have to have the same number but opposite signs. So negative 4 plus 4, that gives me 0, right? So those eliminate. If I had 6, then I would have to have the other one to be negative 6 so that, again, it cancels out. Okay? So if we look at this first equation, I see my 4 and my negative 10. They're opposite signs, which is great. However, there's nothing that I really can multiply by 4 to get to 10 very easily. Okay? So let's look at y. Now, y are different sides. However, I could just multiply this top equation by negative 11. So that would turn this into a positive 11y, and then that would cancel with that one. So we'd only have to multiply one equation. Either way would work. So I'm going to multiply the top one by negative 11. Again, it's a negative 11 because I need to change the sign so that these are opposites. So I'm going to go through and I am going to multiply everything by negative 11. So I have negative 44x plus 11y equals, so then I'm going to take my calculator, 18 times negative 11 gives me negative 198. Now the second equation, I did nothing to it, so I'm just going to rewrite it exactly how it is. All right, now we're going to add these two equations straight down like you would old school style of addition. So negative 44 plus negative 10 gives me negative 54x. The 11s cancel, that's what we wanted. And then I have negative 98 plus negative 18 gives me negative 216. Then our final step is just to divide. And x equals 4. Once I know what that x equals 4, I then can plug it back into 3 different equations. It doesn't matter where you plug it back into, they'll all work. That was the purpose of solving the systems. Okay, so if I plug 4, I'm going to go back into the first equation. So 4 times 4 minus y equals 18. So I have 16 minus y equals 18. Subtract 16. I get negative y equals 2. Again, your y can never be negative, so we're going to divide this by negative 1. So y equals negative 2. So we write our solution as 4, negative 2. Okay, so you can do that same method where you only multiply 1. If you look at this one right here, number 12. So if I multiply the top, if I want to get rid of the x, I could just multiply the top by 4. So then we have negative 12x minus 12y equals negative 8. The second one, we're just going to leave as is. Oh, I'm sorry, that'd be plus. I apologize. 4 times positive 3. And then negative 24. And then you'll notice what happens here. We're adding these. Negative 12 plus 12, well, those cancel. 12 plus negative 12, well, those cancel. So I'm left with nothing over there, so 0. Negative 8 plus negative 24 gives me negative 32. Does 0 equal negative 32? It does not. So then we say that this has no solution. Okay? All right, you can try number 13. You should be able to do that one just by multiplying one equation. So I will give you a hint. I would multiply to get rid of my y's. Okay? Now, it doesn't always work out to where you can only multiply or only have to multiply one equation. So sometimes it's going to happen when you have to multiply both equations. So in this case, if I look, there's nothing I can multiply here. There's nothing really I can multiply here. It doesn't matter which variable you get rid of. I'm going to choose y just because they're smaller numbers. It doesn't really matter. You could also get rid of x. So they're already opposite signs of each other, so that's great. So I don't have to multiply by any negative. So what I'm going to do is I'm going to multiply the top equation by the coefficient on the bottom equation. So I'm going to multiply the top by 4. And then down here, the second equation, I'm going to multiply by the coefficient in the first equation, 3. Now again, I ignore signs because I want to keep all the signs the exact how they are. I don't want to change any signs. So if you want to keep the signs the way they are, then you have to multiply by positives. Now, the biggest mistake or where students make their mistakes is they forget to multiply everything in the equation by 4. Sometimes they forget this last negative 9 times 4 and leave just negative 9 there. So make sure you multiply everything by the number out here. All right, so when I add these together, 16 plus negative 15 gives me just x or 1x. These cancel. Negative 36 plus 33 gives me negative 3. X is already isolated. We already found out that x equals negative 3. Now you have 1, 2, 3, 4 spots that you can put that negative 3 into. Okay, I'm going to choose to use the second one down here. Negative 5 times negative 3 plus 4y equals 11. So we have 15 plus 4y equals 11. Subtract 15 from both sides, and you get negative 4. Divide by 4, and we get y equals negative 1. So my solution here is negative 3, negative 1. Okay, so again, all you're trying to do is cancel out either the coefficients in front of the x or the coefficients in front of the y. In order to do that, they must be the same number but opposite signs, one negative, one positive. And so you can multiply your equations by whatever you need to multiply them by in order to make that happen. Okay, so try 15 and 16. If you have any questions, just contact Mrs. Carlock.